Hi, this is Mark from GradeHub, and I'm here with Dr. Jennifer Balogh, the founder and general manager of Intelliphonics. Dr. Balogh has many years of experience working in assessment and is the author of a practical guide to creating quality exams. Jennifer, thanks for joining me.
Thank you, Mark. I'm very excited to be here.
Jennifer, what motivated you to write your book?
Well, I've always been interested in the ways that teachers have graded. For example, some of them would use rubrics and others would use different algorithms for curving grades. But it was really only when I became a grad student and I was actually writing my own exam questions and grading exams and actually looking at statistics for items on exams that I realized how much I didn't know. For example, I would come across an item because I would see, printouts on the wall, and I would see that only 4% of the entire class of 100 students, let's say, got an answer correct. And I wondered, was that a good question, a bad question, or was it just a difficult question? And I didn't know the answer to that. Then my career path actually took me right into the center of assessment, and it was through an acquisition. And I started working for a large test publisher. And from there, I started learning about testing theory and using it in a practical way. And now I know the answers to those questions. And I want to be able to make that information accessible to people who actually use it. They're hired out there as experts in their fields without a lot of the training and assessment. And so this is the way to get that information out to the people who actually need it and use it because they're using assessments in their jobs every day.
That's great. So along the vein of helping instructors write better exams, could you share some of your thoughts on tips on what makes a good test?
Absolutely. There are three main things that make a test a good test. And that information is coming from a book of standards that's written about tests and what standards you need to follow. That's mostly for professional tests, but they do mention in this book that classroom tests really should follow the same kinds of guidelines. First and foremost is validity, and validity is measuring what it is you're intending to measure. In the world of academia, any kind of knowledge or skills that you're trying to understand in terms of whether the student has that knowledge or not is what you're trying to measure. And there are three different things that you want to make sure that you're doing in order to make sure your test is valid. One is you want to cover the appropriate content. And the way that you can do that is creating a blueprint of your test just to make sure that the proportion of questions that you're asking covers what you want to be covering in your course. Second, you want to make sure that you're asking questions in a relevant way, and usually when you're just providing information in a class, multiple choice is a completely relevant way to do that. A place where it wouldn't be so relevant is if you're teaching some kind of driver's ed and you only have a written component, but you're not actually testing someone's ability to drive. There, it's not so relevant to what you want to do. You want to make sure you're testing in a performance, you want to make sure in a performance assessment situation that you're testing the actual skill.
Sure, you want them to drive then.
That's right. You actually want them to drive a vehicle and show that they can parallel park, that kind of thing. In a classroom, multiple choice, asking questions is the way that you're doing it. Because if you think about it, what you're doing is you're not measuring something physical, you're measuring something in someone's mind. And the best way that we know how to do that is getting information from questions that we're asking on an exam. The third thing that you want to do to ensure that your test is valid is you want to be able to discriminate those students who have mastered the material from those who have not. And so one way that you can do that is make sure that your items, individual items, are showing that discrimination. And GradeHub has great tools and statistics that it presents to teachers so that they can make sure that their test is able to discriminate.
Oh, well, thanks Thanks for that. Now, one of the things that, I see a lot is, in the area of reliability. And I think that many instructors don't have a great grasp of it. Can you share a little bit more about that?
Sure. So that's another very important about what makes a test a good test, and that is reliability. What reliability is it's basically consistency. It's precision. So if you take a test on one day, will you get the same score as you take it on another day? There are a lot of different factors that come into play that make it so that those test scores may not be precisely the same. And a great example is a bathroom scale. So you get on that scale multiple times just within 5 minutes, and you want that scale to be able to give you the same weight every time. If it does, then that's a reliable scale. There are different things that can make something not so reliable, and it can come from the person, but also the measurement instrument. You can imagine with the person, if you're using a bathroom scale analogy again, if you're getting on that scale and then you have chocolate cake for dessert, and the next day you get on the scale again, you may see some differences, and that's because you, the person. That also might be the case in an assessment. Students may have a good day one day, a bad day another day, and that could affect their performance on a test. But sometimes that difference can be caused by the measurement instrument as well. So the scale might be off a little bit, or your exam might be off a little bit. And that can cause the reliability to not be not high. So that can cause the reliability to suffer.
Yeah.
What you really want is high reliability with good validity.
Now, I get this a lot. What's your recommendation on reliability? And maybe you can go a little bit into that.
Sure. I'm very much used to working with professional test publishers, and they're shooting for reliability that's extremely high in the 0.90s. That's not going to be realistic in the classroom. We understand that instructors are not in the business of selling their tests professionally. And so that level of reliability can be relaxed quite a bit. Basically, there's no hard and fast rule, but generally a test that is 0.7 and above is considered reliable. In the classroom, I think that can be relaxed to 0.5 or above. If you're getting below 0.5, then you really might want to be looking at ways in order to increase the reliability. Now, there are different ways that reliability can be estimated. What I mentioned before was taking a test one day and then taking a test the next day and making sure that those scores are the same. There are other techniques that you can use in order to estimate the reliability, where you're getting similar numbers just from one test administration.
So Jennifer, how would, so if I have a low reliability on my exam, what are some of the things that I should be looking at doing at that point?
Sure. There's a mathematical relation between the number of items in your test and the reliability of that test. So the easiest thing that you can do is make your test longer in terms of increase the number of items. That said, if you're adding items that all students get right or all students get wrong, you're actually not adding a lot of information to the test. So you want to make sure that the items that you're adding are also good. But generally, increasing the number of items is a good rule of thumb of how to improve reliability.
If you were using old tests, would removing poor performing questions be another way to increase reliability?
Absolutely. Yes.
Okay. Now, here's a kind of a overall kind of how validity and reliability interact with each other. Maybe you can explain this graphic a little bit.
Sure. And this is a good thing to talk about because the two factors, validity and reliability, interplay with each other. They do. So in the upper left, you can imagine a test. In this situation, we're looking at a bullseye. And if an arrow hits the same spot on that target, if it's consistent about where it's hitting, that means that it's reliable. If it hits the bullseye, which is what you're intending to measure, that bullseye, if it hits the bullseye, then that is in this graphic is showing that the test is valid. So in this upper left-hand depiction, you've got the bullseye, and you've got a scatter of different points, which is telling you that it's not very reliable. And also, all of those points are in the upper portion of the target. They're not really hitting the bullseye at all. That's giving you an indication that it's not a valid measure either. So in the upper right side, you could have all the arrows really going for that bullseye, but you can see that there's a scatter again. That's a situation where it's unreliable but valid. In the bottom left, you have an example of where the arrows are hitting pretty close together, but they're missing the bullseye. So that's an example of being reliable but not valid. And then finally, what you're shooting for when you're creating these exams is both reliability and validity. So that's where the arrows are hitting the bullseye in a very narrow band.
Okay, awesome. So, you know, maybe we can go through a screenshot of the overall exam statistics in GradeHub. And can you go through this summary report here and give us some of your thoughts?
Absolutely. Let's go through this. It's all great information to have. First, the report is showing you the number of students. That's good to know. I mean, you instructors, of course, know this, but it's a good reminder that if you have a smaller group of students, you might see different trends associated with that group as opposed to things can smooth out with a larger group of students. For example, if it's a small group, maybe this group is very proficient and they're fast learners, and so maybe they're a little bit skewed to what you're commonly seeing with the larger classrooms. You're going to see those effects a lot more with smaller groups of students in smaller classrooms.
Would that affect test reliability too? I mean, so if you had a really small class, you might have, you know, some effect on your reliability?
Yes, it can.
Okay.
So if you have a group of students and they're kind of homogeneous and they're performing the same way, you're not going to see as high of a reliability. Reliability really depends on the group of students. You tend to see higher reliability if you have a large range in your performance of your students. The number of exam questions is also a great thing to be able to see at a glance. And as we had talked about, it has a direct relation to that reliability. Shorter exams with fewer questions will tend to have a lower reliability than those with many, many questions. But again, you need to balance everything. Sometimes also just keep in mind that the reliability estimate that you're seeing here, that's the next thing under the exam questions, under test reliability. Again, what you're trying to shoot for is something greater than 0.5. 0.6 or higher is even better, and the higher you get, the better. What that's actually telling you, though, is not the performance, of course, from day 1 to day 2 on the same test, but rather an estimate of that based on one test performance across your whole group of students. And so what it's really telling you is about internal test consistency. So it's called internal consistency. That's the kind of reliability that it's showing you. You may have a situation where you don't want your test to be asking all of the same kinds of questions, of course. And so you may want some range. And so keep in mind that the test reliability here is talking about internal consistency, internal to that test. And if you ask the same kind of question over and over and over again, it's going to be highly reliable. But that's really not what you're doing in a real testing environment. So if you're getting reliabilities that are 0.98, that's not necessarily what you want either, because you want that test to be covering a lot of different content areas, you know, reflecting of what you're covering in class.
Interesting. Now, what's the difference between median and mean scores?
Sure. Mean score is just another name for an average. We're all pretty familiar with that. It's good to be able to see that mean score along with a median. What a median is it's the middle score. So if you were to rank all your scores from highest to lowest, let's say we have 10 here, it would be the middle score. If you have an even number like 10, then you're going to have two middle scores. So the median is the average between those two middle scores. And the median is interesting to look at because unlike the mean or average, it is not influenced by an outlier. So for example, let's say students didn't do so well as a cohort on your test and they scored maybe 70% on average. What you might see is that you have most people scoring around 70%, and a couple of people who are scoring, who aced the test and got 100%. You're going to see that reflected much more in the mean than you are the median. So the median is kind of immune to that kind of pull from an outlier.
Interesting. So yeah, so that's maybe why instructors, whenever they're using, for example, Z-scores, which we have in our student report, sometimes they'll use their curving based off the median versus the mean. You know, does that make sense?
It does. It makes absolute sense. Yeah.
Now, standard deviation, I've had enough statistics, but I'm always rusty on this. So what is an instructor looking for in their standard deviation?
Sure. The standard deviation is a way to quantify the spread of your distribution. So if you have a large standard deviation, it means students had a large range in their scores, so all the way from the bottom to the top. If the standard deviation is small, it means that most students were scoring within a very small percentage. So you can use this information to try to understand your test and whether it was too narrowly focused or not. Again, it will depend a lot on your students and their performance.
Is there a range for standard deviation that you're looking for, or is it, is a larger standard deviation better than a smaller one?
It really depends on the test. You can't really give it a number because it will change on every different test in terms of the number of students and the number of questions. So I can't just give you a number and say shoot for this.
So we recently switched to alpha versus KR20, and I was wondering maybe if you could go a little bit into the similarities and the differences between those measures of test reliability.
Sure, that's a great question. KR20 stands for, well, the KR20 stands for Cooter-Richardson 20, which is the 20th equation that was presented in a publication that they had, an article they published in 1937. And it was a way to estimate reliability. A common way to do that before we had a lot of computing power back in the day was that you would do a split half. So basically you would take the even numbers in a test and the odd numbers in the test and a student's performance on those across all your students, and you would correlate. And if the correlation was high, it was an indication that the reliability was good. The KR20 was a technique to do that so that you could kind of look at all different possible ways that you're splitting up a test, because you could do the first half, the second half, the even, the odd. There's a lot of ways that you can split it in half, and KR20 was looking to normalize that. Cronbach took a step further and kind of liberated this estimate from needing to be dichotomous with dichotomous items. Dichotomous meaning you either get it correct or incorrect, and kind of looked at it in a different way by using an ANOVA. But the bottom line is that KR20 and alpha give you the same answer if you're dealing with dichotomous data. So they're mathematically the same, basically. It's just that the Cronbach alpha allows you to make reliability estimates when there's partial credit. That doesn't mean that you have to use KR20 when it's dichotomous data, and you have to use the alpha when it's partial credit. You can use alpha for any of those situations, just because it's a more generalized equation.
Yeah, thanks. So, I've actually had people, in the field will see a multiple choice question that has a single response, A, B, C or D or E, or true false, and they automatically think that a multiple choice question is not dichotomous. And that's not the case, right? So, if it's a straightforward multiple choice question with just a single response, correct response, then KR20 and alpha would have the same exact measure. Is that correct?
Absolutely. So if you have a multiple choice question and you have A, B, C, D, or E, and you choose C, and that's the correct answer, you're either getting that question right or wrong. So it's actually dichotomous.
Interesting. Yeah. So thanks for clarifying that. Well, Jennifer, thanks for sharing all your insights. To learn more about GradeHub, visit or schedule a demo on our website at gradehub.com. Thanks for joining.